Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So in the previous video we have discussed the two problems from DFS, which was left view and right view, but using the DFS traversal. Now in this video we'll see the same questions, which is left view and right view, but using the depth first approach. So let's try to understand with the DFS approach for the left view, and then similarly we'll do for the right view. So what was the DFS approach? We start with the root and then we either go for left side or right side, correct? And if you remember, while traversing through the depth first search, we have no idea how many levels will be there. So in the level or a traversal, we were not able to decide ki how many sublists we have to create. So how we decided, first we check initially ki what is the size of this initially. So it was size of, so it was 0. Now we started with level 0 from parent, and to their children we have given the parent level plus 1, correct? So that they both will be identical with some variable. So that were the level. So now when we started with this level is equal to 0, initially our answer array, means the outer array, was 0. So size was also 0, level was also 0. So we decided if the size matches with the level, we inserted the new sublist, correct? Okay. So what was the code? In DFS, we were sending root also and level also, correct? Now the base case, ki if our root was null, what we did? We returned from there. Done? Now what we did, ki if our level matching with the array size, array dot size, and array is nothing but that outer, this one, this is nothing but the outer, okay? So if it matches, what we did, inside the array we added new array list. Remember? Yes. So here also we can insert, but we already discussed na ki why we are inserting all the nodes when it was only required to insert the very first nodes, correct? And also I can say ki when I went there with the very first node, which is 1, I checked the size of the array was 0 and level was also 0. So I decided to put a inner sublist. But now this time, instead of putting the inner sublist, why not to put that node value? So what I said, instead of putting this inner sublist, let's insert array.add nothing but node dot value, and that's it. Now go for the DFS root dot left call, in the left level plus 1. Similarly DFS root dot right call, again level plus 1. That's it. Now what I did, let's do the dry run to understand this. Okay, what I said, first in the stack call, first our function 1 will go with level 0, and now initially our answer size or array size was 0. So we saw ki hey, array size or answer size is also 0 and the level is also 0. Okay, so instead of inserting the sublist, do one thing, insert this node value which is 1. So we will insert 1. Now we will go for the left child, means function 2 and level 1. Again we will check level 1 and size is also 1. Now instead of inserting the new sublist, insert this node value which is 2. So we will insert 2. Now we will go for left child, which is 7 and level 2. Now again we will check size is 2, level is 2, means here we want one more sublist. But again instead of sublist, what we are trying to insert? Value 7. Now you will be thinking ki like we have inserted 1, 2, 7, we can insert 3 also na? No, it won't happen. Why? Because 7's left right is nothing, is not present, so will get returned. So 7 will get popped out of this function call. Now similarly 2's right child does not exist, so it will also get returned. So 2 will also get removed from the stack call. Now we'll go for the this, which is parent 1 and level 0. Now you will go towards the right side. So for the right side, what we'll call function 3 and level 1. But we will see level is 1 but the size is not 1. So we will not insert anything. Okay. If you remember previously when we did level auto traversal with the depth first search approach, there also we did ki when we came on this level, which is 3, we found ki the size was already present. So previously only we have created a sublist for it. So we just inserted 3 inside it, correct? But we don't want to insert 3 anywhere, correct? So hence we will skip this. Skip this means ki if the level is not equal to array.size, don't do this. Okay, if it is equal, then only add. So now for 3, level is 1, size is not 1, means in place where 3 is present, this is not the first child in that level. The first child has already occurred and we have already inserted in our array. Okay. Again for 3, where will go? 3 dot left child, which is 4. So 4 level 2. Similarly, level is 2, size is 3, means wherever 4 is present in that level, before 4 there has already been one element occurred earlier. So we have already inserted that. Now we will go for 4's left, which is 6, and now level 3. Now we will see level is 3, size is 3, means this is new. New means we will insert 6 in our array. So we will insert 6 in our array. Now 6 left child and right child does not exist, so we will remove from the stack call, correct? After removal of this, again we will go back. For 4 also right child is not there, so we will go back. So 4th call will also get removed. Now for 3 we will go towards right side. So function 5 and level 2. Now the level is 2, size is 4. So hence wherever 5 is present, there has already been a node present earlier in that level. So means 5 is not supposed to go inside it, correct? Means it will violate the left view if you will insert this. Okay, so we will skip this. Again we will go for 5's left child. So function 7 and level 3. So we will see level is 3, size is 4. So this is not required, because wherever 7 is present, there has already been one element occurred before it. That's it. So we will go back. 7 does not has left child, right child. So from stack call it will get removed. We will go on 5. 5 does not has right child. So 5 will also get removed. Now for 3, left already has been returned, right already has been returned. So now 3 will also get returned to 1. So 3 call will also get removed from here. Now similarly for 1, left has been returned, right has been returned. So we will, like this call also get removed from the stack call and the stack will become empty, and this is the answer which we were supposed to get. Is it 1, 2, 7, 6? Yes. Okay. So this is our code. Now this is so for left view. If you have to do with right view, what are you thinking? Like what can we do? First thought comes in our mind ki okay, 1 has been there na, 2, let's update it, 3, then with the other number. Now 7, okay, update with 4, now update with 5, okay, but this will become messy. Don't you think ki in this depth first search approach, from the root child, you went towards the left child and that level was new, so you inserted 2 first. Yes. So from the root, if you go towards right child, for that also the level will be new and size will be exactly matching, so you will be inserting 3 instead of 2. Similarly, when you will go towards right child, again for 5, this will be the first element for that level. So you will insert 5. So the only line of change of code which you have to do is, ki instead of this, you have to write right first and then left later, and that's it. So what's the time and space complexity here? If you saw how many number of elements you have inserted in the stack call, can I say 1, 2, 3? First you inserted 1, then for 2, then for 7. You popped 7. You popped 2, and then you went towards 3, then you went 4, then you went for 6, then you popped 6, then you popped 4, then you went towards 5. So after 1, 3, 5, then 7, correct? So can I say in the worst case also, you can say ki only this much, like 4 times you have inserted, this is nothing but levels log n. In this case where it is around full binary tree, but think about, you have like this tree, 1, 2, 3, 4, 5 and this 6. So number of nodes are 6. So as per 6, if you are thinking for log n, it will be very less, correct, 2 point something, but you have called for 1, 2, 3, 4, 5 continuously na. So the number of calls depends on the maximum height also. So it does not mean that every time the tree will be full binary tree. Okay. So if it is like every child, like every node will have 2 children, then you can say the space complexity will be log of n. But if you have a tree like this where it has only left child and somewhere around right child, then you can say O of n. So it depends on the structure of the tree as well. Now talking about the time complexity, what is the time complexity here? Can I say for every node we have called the functions? So the time complexity will be O of n, where n is the number of nodes, correct? Okay, so this was your DFS call for left view also and right view also. So let's see this code in the editor. So here is a code for left view where we are checking the base case, and if level matching with the size, then only instead of inserting the new array list inside the array, we are only inserting the first root value. That will be the left view. Why that will be the left view? Because you are going towards the left child first and then right child. And if you will just swap this to right child first and then left child, it will become the right view. So I hope you understood both the code with DFS and BFS. Okay, and this code was possible with both the approaches. So if you understood, this was your Java code, here is your C++ code with a similar approach, and here is your Python code with a similar approach. Here, as you can see, we have just swapped these 2 lines and it has become the right view of the binary tree. So this is your Java code, here is your C++ code, and here is your Python code if you are from Python background. So let's try to submit any one of these and done. So if you understood both left view and right view, then definitely you can mark these 2 questions together as done. If you understood, please hit the like button of the video and let me know in the comment section if you have any doubt. I'll attach the sheet link and my social media links in the description. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.